Hello, I want to go over steps to follow to complete the retention data mining project. This was outlined in the SAS textbook, chapter 3. So first thing is we'll create a new project. And I'll give a name. Call it retention data mining demo. Alright, and next thing is we need to create a library. So we click on File. Wait a minute. Create data source. SAS table. Browse. The library is not here, so I need to create the library first. So I'll click on New Library. I have already saved the data file on the space for our course. Let's call it okay. Path. For path I will use /courses /DC197 CE5BA27FE300 and click finish. So I've named the library ABA, and now that we have ABA has been added, I can create a new data source and click on browse ABA, and that is a folder called file called retention. So it's going to be, table is going to be aba.retention. Click next. So there are 2,626 observations, 21 variables. It's already cleaned up. Let's select advanced and customize, and so advanced options. Missing percentage threshold is 50. So as you hover over each property, you get a description of what that property means. In this, we'll change the class count threshold to 2. Click OK. Next. Now these are the list of variables, and these variable names and descriptions of these variables can be found on page 316 of the textbook. going up to the last page of the wizard. Now the data source has been added. Now we can start viewing the data set. Okay, let's go to options and preferences. Here we have preferences for this project that we can change, and sample method. If you want to do the entire data set, by default you can specify a random sample and max, the maximum number of observations, and random seed we can change it. We can fix the size to some default value or max, the highest possible. And the max size is smaller than, the max size is larger than the number of observations we have, so there's no need for any change here. Okay, now we can quickly take a look at the data set by right clicking on the data source and go to explore. Okay, here's the exploration screen, and as you can see on the right side here, for each variable it shows for each interval type data we have minimum, maximum, mean values, and for the nominal type data we have the number of levels, and alright, the actual data, some of the data can be seen here. Okay, now this is an interactive results report, so here you can go and do a plot of the target variable. So let's do a bar chart of the target variable, which in the case of a retention data set is this one, and the target is the category type target, and we can show the result as a percentage of barcode values. Okay, and click next, finish. There it is. So 87.28% target 0, and the remaining is target 1, 12.72. Okay, alright, so, and we can the plot was just on the fly type of a plot. Okay, you can produce another plot, let's say by some other variable such as fall GPA. And that is fall GPA is numeric, so let's do a histogram. So the fault GPA histogram looks like this. Okay, now you can right click on this and change the number of bins. It's 10, make it 100, so it looks more defined. You can make it even larger. Alright, so these are the finite number of values under fault GPA. Now this is described on page 336 and 337. Next we'll go to page 345. Alright, so let's go ahead and create a new diagram. SAS Data Miner is a system that has a graphic interface, so you can create projects simply by dragging objects onto the sort of canvas here. So now that we have opened, you can drag the data source to here, and it uses the SEMA model, sample, explore, modify, model and assessment. So under sample tab we have a bunch of options for partitioning and filtering and so on. Under the explore tab we have options for cluster analysis, graph explore and so on. One of the things we want to do is stat explore, so should be under there it is. So we connect the output from retention to the input part of stat explore. Stat explore, once we highlight stat explore, the property of that stat explore node becomes available. There is not much we want to change here, so let's go ahead and run this. You right click and run. Now in this data set we have already defined what the target variable is and what the input variables are, so it's going to help us learn a little bit about the association between input and output variables. Alright, so to learn the association between two variables, we can use chi-square or distribution. And chi-square is a way of associating two categorical type variables. Now it finds that the highest value for chi-square was between target and transcript. The second highest was dropped course and transcript, and third highest was legacy num and target and so on. And for the other type of variables such as numeric type variables, fault GPA happen to have strong link to the target variable, followed by percentage hours completed and so on. So a quick statistical exploration gives us some understanding of association between the variables, and also we get some summary statistics right here for the interval variables on the training data set. Okay. Alright. And notice notice sometimes the skewness is way too high, like 25, so it's definitely not normal. If it is close to 0, that's normal. You could say approximately normal. Alright. Okay, next what we'll do is, what I'll show you is how you can partition the data. So go to sample, and there's this node called data partition. Connect retention to data partition, and then the property of data partition, you have data set allocation. We'll change training to 60% and validation to 40% and test to 0%. Okay, so we are going to use 60% of our observations to figure out a model, and then 40% of the remaining observations will be used to validate the model. Okay. Alright. As we continue, we are switching to page 359 of the SAS book, and here's where we are introducing decision tree to our project. So choose model and select decision tree, connect data partition to decision tree. Let's go ahead and run this. So since we have already defined the target and the input variables, it'll automatically pick all the nominal type variables and try and build a decision tree based on that. Let's take a look at the decision tree results. Okay. Alright, let's see. If you have a book next to you, you'll notice that fit statistics panel, here it is. It shows you the misclassification rate is 0.092. That's about 9.2% misclassification for the validation data set. The average squared error is 0.081 for the validation. For the training data set, the misclassification was 0.08%. I mean 8.1%. And the tree panel is right here. So you maximize it. If you maximize the tree panel, it says we observe the tree has 7 leaves. So we have 1, 2, 3, 1, 2, 3, 4, 5, 6, 7 leaves. So there are 7 probabilities. Okay, probability of value 1 for this tree node number 8 is 100%. For the second node, or node number 14, the probability is 0.7667, 0.3333, 0.875, 0.2083, 0.95, 0.072. Okay. Now remember, the problem was trying to come up with a model that will predict whether the student will come back the following semester. So that means value of 1. Alright, so now for our classification problem, we will choose any probability that is above 0.5. We'll treat that as a 1, meaning he will come back, and I'm sorry, meaning they will not return the following semester. So if you add these numbers, 31 plus 30 plus 8 plus 20, that adds to 89 observations, so 89 students. Okay, alright. Of course, this model, or the decision tree model that you see, came from trying different trees, and we can see that the number of leaves that we have ended up with was a final model. Okay, now for each node we also have for each leaf we also have a leaf statistic as to what training and validation percentages are. Okay, and another important part of this results is the classification table. Okay, and we already seen the misclassification rate. In the classification table, let me go ahead and maximize this. It shows you, here it is, classification table. Okay, and for the training data set as well as validation data set, it comes up with 4 numbers, which is your false positive, true negatives, true positive, false positives. Okay, now if you remember from an earlier class, we can think of a 2x2 table, a contingency table, and let me show you using a small Excel example. Okay, the misclassification rate is 0.081 for the training variable. So if we go back to our data set, our results from the training data set. We have the frequency counts, which has been placed inside this Excel sheet. So 9 and 120, these are two misclassified sets of observations. So misclassification rate is given as 9 plus 120 divided by all the observations. It's 0.081. That's what we find, of course, from our original results here. So misclassification rate is a good measure of figuring out how good the model is. Okay, so that was the first model, the decision tree model. Next we're going to try and set up a regression model, a logistic regression, that will explain the target variable in terms of the interval type input variables. So let's take but then before we do that, we need to get an idea about what our input interval variables look like. Okay. Now there is a quick and easy way to do a histogram for all the interval type data. So to do that, you click on the first input data node, and in the properties you click on variables. Now this will allow you to pick variables for quick analysis, and these are lists that can be sorted. I sort everything on level, so all the interval type data are bunched together. So simply highlight all of them, and once it's highlighted, I can then do explore and be prepared to be surprised. Here it comes, just 1 minute. There you go. Okay, so we have a histogram of all those variables in one shot. So that's cool. Alright, and so we have the data here, we have the sample statistics here, and for each variable we have a histogram. Okay, and each histogram also shows you the corresponding values as you pick any one, how it's distributed. Say for example, let's say I'm looking at SAT score between 920 to, let's say, 1040 or something, and it shows how it is distributed in terms of major rate and attended hours and so on. So you can quickly see some correlations right there, and also you can see how the data is distributed and how it's not symmetric. And SAT score is somewhat symmetric, everything else is not symmetric. And one of the things, assumptions about regression, is that the independent variables are approximately normal, which means they have a symmetric distribution. Now these naturally don't have a symmetric distribution, so we need to somehow convert them or transform them so that they become approximately symmetric. Alright, now that looks like a tall order. How do you do that? But fortunately there is a node in SAS Data Miner that will do it for us. Okay, So only thing that I think is sort of symmetric is the SAT scores. Distribution, everything else needs to be transformed. Okay, now to do transformation, there is under modify, we have okay, it should be under drop, impute, interactive, principal components, replace, transform variables. So drag and drop transform variable, and we want to do the transformation after we do partitioning. So connect data partition to the transform. So in the transform variable, we need to say how things have to be transformed. So highlight that, and let's go to the properties. If you click on the variables under train, so these are the variables, and we want to transform these variables, and method by default is default method. And what I want to do is I want to all the interval type data except SAT, I want to transform them so that they become close to normal distribution. So I highlight, let's say high school rate, and then pick instead of default I'll pick max normal. And same with every other interval type input variable except SAT. I could have done all of them in one shot by highlighting it and then drop this open. Oops. Okay, once you're done, and click OK. So that should take care of transformation, and it's automatic. So let's go ahead and run this. That's done. And so what it has done is it has created a transformation, and we want to see what the newly created variables look like. And so I go to exported data, then where it says train data set, and click on OK. Explore. Just like when we did the explore on the original retention data set, this will let us do exploration on the new data set. Okay, now this one shows all the variables. Okay, and as you tell, there are some transformed variables. Look at that. So under label name, if you look at it, this transformed extracurricular, that is a log transformation of extracurricular data, and attempted hours fall, that's a power transformation, and then there is square root transformation. All transformation has been applied. At this point, what we can do is we can take a look at the plot of these newly created variables. Let's take a look at the histogram of let's pick distance. So distance got transformed into square root. So the original distance, make it x-axis and percentage, looks like that. That's the original distance, whereas the modified or transformed distance would look like that. Okay, so there is a little bit of transformation, so this is the best we could come up with, and SAS takes care of it. Okay, it takes care of how best to transform the variables. Okay, all right. Okay, the next step, as described in the book, is to use the impute method. Impute node lets you fix the data before you start using it in any kind of regression analysis. There may be missing values or data that is that need to be fixed, and use the impute node, and so there it is. So after we do the transformation, we connect transform to impute, and then under impute properties, where it says indicator variables. Okay, so where it says default target method, tree surrogate for the imputation method of class variables. So choose tree surrogate. In addition, make the changes indicated below to indicate the variable panel, subpanels, class variables, and interval variables. Under indicator variables, make this technique and role change that input. Okay, once this is done, we're ready to add the regression model or regression node to our data set. So go to model and pick regression and connect regression. And the type of regression we see here is really much more powerful than the standard regression we had earlier seen. And this regression, remember, regression is a way of relating one or more quantitative variable with the target variables and come up with a linear expression or equation describing the relationship. But if there are 10 independent variables, now not all 10 will be useful. some may be not useful, so it doesn't make sense to plug in all 10 variables in one equation and then see which is the best, what the fit is. What if only 9 of the 10 variables are useful? Now you don't know which 9, and so now thing is, if there is a subset of input variables that sort of best describes the output, best describes the relationship, then we want to know what that subset is. Unfortunately, if you try to do it manually one by one, that's going to take a long time. Then statisticians have figured out a way to quickly find the best fitting linear relationship between the input variables and the output, and that method is called stepwise linear regression. So the way we're going to select the best model is through stepwise. Okay, and the selection criteria will be, we will fit one model. Let's say out of the 10 variables, let's pick 6, fit a model, and see how good it is in predicting the validation data, and then keep a record of that. Then pick another model, add another variable or drop a variable, then again see how good the new model is in predicting the validation data, keep a record of that, and so on. And you keep doing it over and over again until you have figured out a best model that minimizes the error, the validation error. Okay, so you do all that simply by picking these two options under the regression panel. And also there are a couple other things the regression needs to the default regression parameters have to be modified a little bit. Okay, so if you go to, after you've done this, if you go to selection option, use selection default, no, then choose options and entry significance level. So we will put every variable in the first time, and we'll keep them in, even if they may not be very good fit in the beginning, and everything else will leave as they are. Number of steps, I'll go to 30 different stepwise regressions. Click OK, and once we've done this, we are ready to run our regression. And let's go ahead and run this. So it's going to do a whole bunch of things: opening the retention data set, do a data partition, do transformation, then do imputation, then do regression, all that. Once that's done, it's going to show us the results. Alright. So the coefficient has the highest effect, followed by okay, wait a minute. Okay, the first one is IMP PWR HS rate. So that's a transformed high school rate, is the most, I guess, strongest explanator, followed by percentage hours complete in fall, followed by fall GPA, followed by dorm rate, followed by transcript 0. So these are kind of important variables to describe, to be considered, and it has come up with the result. Okay, alright, so it has gone through many iterations to come up with the best answer. Now if you go to view under model iteration plot, you see that it has on the y-axis is the average squared error, and okay, there are other means of measuring how good a model is. An average squared error is what is used, and the lowest value is attained when we did on, I guess there is step number 5. So it has automatically placed this blue line right next to step number 5, saying that is the best stepwise model. So how do we find out what step 5 is? Okay, now in the output screen it goes through each steps. Step 0, then followed by step 1. Okay, so it adds percentage hours complete fall entered, then it does the calculations and does compute objective function. Then it goes on to the second step of adding another variable to the model, and then it computes the objective function, alright, and so on. So and it keeps doing that. Step step 5. Okay, so step 5 is where we have apparently best result. Okay, that is what is highlighted, but later just the last result in step 22. If you scroll down, we go ahead and find step 6, 7, 8, 9, 10. Okay, close this. So step 22 was the last one. Okay, so it adds as well as removes variables as deemed fit. Then finally it comes up with a list of variables that are in the final model. Okay, so here you go. Okay, all right. Okay, so we want to look for the maximum likelihood estimate table. This one. Okay, transformed fall GPA, transformed high school rate, transformed dorm rate, percentage hours completed fall, and transcript 0 or 1. So it gives us the best list of variables. Okay, you can also take a look at the classification table, and there it is. Okay, so classification table tells us what our target and outcomes are. Now, just like we did for the decision tree outcome, we can do something similar for the regression analysis also. Okay, So regression analysis outputs are right here on the training data. If target is 0 and outcome is 0, that's 1351. If target is 0 and outcome is 1, that's 23. If target is 1 and outcome is 1, that's 85. If target is 1 and outcome is 0, predicted is 0, that's 115. So that way we calculate the misclassification rate for the regression analysis to be 0.087, and which is a little higher than the misclassification rate for the decision tree. So between these two, I would pick decision tree because it has lower misclassification rate. Alright, so that's how we can use SAS Data Miner for doing a predictive data mining exercise. Hope it was useful. Thanks.